Welcome to the AI Research Roundup. I am Alex, and today we're looking at a paper from the Papers with Code trending list, published on the 10th of June, 2025. The paper's evaluation of top AI models reveals a significant gap still exists between their performance and human experts when it comes to long-term, complex problem solving. The paper is titled ALE Bench, a benchmark for long-horizon objective-driven algorithm engineering. So, what this paper is really getting at is that many current AI coding tests are a bit like short sprints. They're pass or fail and over quickly. But in the real world, engineers often face marathon problems, things like optimizing delivery routes or factory schedules. These are what the authors call long horizon problems, where you have to keep refining and improving your solution over a long time. They've built a new benchmark, ALE Bench, to specifically test this kind of iterative problem solving, and as well, see, it really puts current LLMs to the test. And for those of you who want to try this out yourselves, the authors have also released the official code for this work. It's a full toolkit on GitHub called ALE Bench. In the repository, you can find everything needed to set up the environment, run these long evaluation sessions on your own AI agents, and even use their tools to calculate the final scores and rankings. Alright, so this first figure gives us a fantastic overview of the whole setup. On the left, you can see the types of problems included in ALE Bench, things like routing, game playing, and scheduling. These are all from past @coder heuristic contests, which are known for these tough optimization challenges, where you're just trying to find a better and better score, not one single right answer. Then on the right, we see the evaluation framework. The AI agent, which is an LLM plus what's called scaffolding, basically a support system to help it code, debug, and tune, interacts with the benchmark to iteratively refine its solution, which is a lot closer to how a human would actually work on a hard problem. So, building on that overview, let's look at a concrete example. This figure shows a typical problem from the benchmark. It's a pickup delivery task. You're given a bunch of locations on a 2D grid, and the AI's job is to write a program that finds the shortest possible route to service a set of these requests. You can see a visualization of one such route on the right. A key constraint is that you have to visit the pickup location before its corresponding drop-off. This is a classic optimization problem where the score is the total route length. The shorter your path, the better your score. And this is a perfect illustration of why that long horizon aspect is so critical. This chart shows the actual score progression from a 2-week-long human competition. The horizontal axis is time, stretching out over hundreds of hours, and the vertical axis is the score. Each line represents a competitor who finished at a certain rank, and you can see that for everyone. From first place on down, the scores keep ticking upwards. They don't just submit one answer and stop. They're constantly refining their code to squeeze out a better score, even deep into the contest. This is exactly the kind of iterative improvement that ALE Bench is built to test. Okay, so given that we see humans constantly improving, this chart helps us understand the overall skill landscape of these contests. It shows the distribution for 2 key metrics the paper uses. First is rating, the solid line, which works a lot like an ELO rating in chess. It reflects your competitive standing. The second, with the dashed line, is average performance, which is simply a participant's average score over multiple contests. The author suggests this average performance is a more stable measure of a coder's typical ability, as a single great result can really inflate that rating score. So with those performance metrics in mind, this table gives us our first look at the results. It compares different programming languages, C++20, Python 3, and Rust, in what's called the one-shot setting. This just means the AI agent gets a very limited number of tries to generate a solution from scratch, without that iterative feedback loop. And what we see is that C++20 consistently comes out on top, achieving the highest average performance and the best competitive rating. But it's also clear just how hard these problems are. Notice that 0% of attempts reach the Expert 2000 performance tier in this setting. Alright, so drilling down from that language comparison, this table gives us a head-to-head of the frontier LLMs themselves, again, in that difficult one-shot setting. The models here are split into 2 groups, non-reasoning models and reasoning models, which are generally designed for more complex multi-step problem solving. And you can see that distinction matters. The reasoning models consistently score better. The standout is O3 High, which breaks an average performance of 1,000, the only model to do so. But even so, the gap to human performance is stark, especially in consistency at higher levels. But that was the one-shot setting, which is incredibly restrictive. So what happens when we let the models work more like the human experts? This table shows the results from the iterative refinement setting, where the AIs get a full 4 hours to continuously improve their C++ code, getting feedback along the way. And the difference is dramatic. Average performance jumps by over 400 points across the board. The standout model, O4 Mini High, achieves a rating of 2104, placing it in the top 12% of human contestants. Now all models are reaching those expert performance tiers. The big takeaway here is really about the process. While today's models can't just spit out a perfect, complex algorithm on the first try, giving them a more human-like workflow with time to iterate and refine their code makes a world of difference. This ALE bench isn't just another coding test. It's a crucial new tool for building AIs that can tackle truly long-horizon engineering problems. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.